Hello, and thanks for joining me for another Precision Flyer Repairs video. This one is about initial engine inspection and some tests that you can run both before you start to endeavor working on one, as well as when you're finished, to check out how well your work has helped the engine to be operational again. I thought I'd start off by explaining these are three engines that were provided to me by a customer. They have a pretty special story to them. I'm going to have another video of them fully assembled and running on the layout when I can provide you more background on those. But I thought I'd use them for the purposes of this video because they're here in front of me and make good subjects for that. First of all, when getting an engine and before doing any work on it, there are a few things that I think are good to check out. I like to drop the side frames off the trucks. This is a 372 Union Pacific GP7 chassis with its truck still here, the dummy or non-powered one in the back, the single powered truck in the front. And with the side frames off, you can get a good look in at the gear bays, as I call them, and see how full they might be of old, congealed, or even in some cases practically petrified grease or Vaseline. That'll give you some idea of the resistance that the motor might be facing. I also check to see how much axle hole play there is, and if it's excessive, then you're going to be able to, get some idea of how much wear and tear there is. This is a chassis that was sent spare along with the engine by the customer, and the original chassis in this was horribly worn, and normally that would get rebushed, but since the customer did provide some spares, and among them was this chassis still in good, fairly unworn condition, I decided to degrease and use that rather than get the other one rebushed. And then I think you're ready to try a couple of other tests. I call it the longitudinal travel test, which is where you rotate a wheel and see how freely that armature will travel back and forth. Another test then is to take a non-metallic object and see how freely that armature spins inside. And if it's a lot of work to spin it, then you know it's going to be a lot of work for the motor when power gets applied, and you'll have some idea as to whether there's even a resistance enough to prevent it from spinning at all, which then you don't want to apply any power to it. Another test is what I call the lateral travel test. That's if you grab a wheel set and move it back and forth, how much resistance are you feeling? If you feel a lot, it could of course be that old grease that's gelatinous, but you could also have interference between that drive gear and the worm above it. So I'd say give it the old grease check, give it the bushing play examination, give it the longitudinal test, and give it the lateral test, just to give yourself a feel for what that motor's condition is. And this is by no means an all-inclusive test or inspection video. It's just to give you a flavor of some of the key things to look for and examine before you start working on something. Then I look at the wiring. Does everything seem to be intact, well soldered? Are there breaks or electrical tape joints or things that look a little suspicious? Test the reverse unit by hand. If it takes a lot of force to push this, of course, this unit solenoid is going to work very hard when power gets applied to try to push that barrel around and give you an appreciation for what it faces when you do, if you do apply power to it. Sometimes people took it upon themselves to actually grease these, which I don't know why they did, but it happened. And many times that grease or Vaseline is in a similar, nearly petrified condition as what you might find in the gear bay. But then at that point, if you feel as though the motor ought to turn, there's travel in play enough that it should be free, that power applied to it ought to show you some signs of life, that you can get this to at least move or position yourself in a contact position, that there would be power to the motor, I'd say it's worth moving to the next step. If you have any doubts, don't apply power to a motor or system that you feel has resistance or impairment enough in it that there's no chance it's going to fire up. Because in that case, you'll just be applying something, applying power to something that's only going to heat up and potentially make matters worse. But let's assume that you're saying, yeah, you know what, things feel good enough that applying power ought to at least get me some response and some initial indication as to what I'm dealing with. And in which case, if you're feeling that way, I would say move on to what we're going to call a hang or no load test. This is where you suspend the engine up in the air with power leads attached to the tops of its yokes in order to get the benefit of power as directly applied to the system as you can, and see what happens. Now, you start off with a low level of power, of course, just to see if things are going to turn enough for you. This engine has been completely overhauled, and this test actually is one that you can conduct and ought to both be for commencing work if you feel comfortable with applying power to something, as well as when you're finished, because this will give you an early indication then as far as how successful your work has been. The second test is behind this one, and that's the roller test. We'll just transfer the leads over to the yokes of the engine on the rollers, test it in that configuration. The thing about the no-load test is, if an engine's going to show signs of life, it'll most likely do it in the hang or no-load test. And that's because there is no resistance being given to the wheels. There's no weight on the wheels pushing them up in the truck and against the worm and armature between them. And it's pretty much, as no-load describes, free spinning opportunity for the motors to perform. The roller test then introduces weight on the wheels and some roll resistance to the drivetrain because of its being on the rollers, and that helps introduce whether one motor or the other is pulling better than the other or getting ahead of the other. And you can see in this case of a dual motor unit how fairly well they're matched. But I thought we'd just do a quick hang test so you can see what that's like. Excuse my reach. And you can see this gives you an opportunity to see the armature spinning, the wheels turning, the reverse unit operating, although my hand is covering that up quite a lot. Here, let me try to move that around. There we go. You can see it better. And give you a feel for how each motor performs against the other one visually, and then also try it at speeds much lower than the activation voltage of the reverse unit, just to see if you get a nice slow cruise, because that'll indicate to you whether there's much resistance mechanically left in the system, and give you again some early indications of what you're starting to work on, as well as how well your work has ended up if you're finished. The next test then is the roller test, and we'll just transfer the leads from that engine to this one that's up on the rollers. And getting a grip sometimes with the alligators takes a try or two. Now this engine, before I test it, I just thought I'd tell you that these have all been overhauled, requiring different degrees of work. This one in particular, you may notice the really nice new rainbow wire. This engine did need complete rewiring. The original harness in it was made up of the original cloth covered wire. It pretty much was a mess, as you might be able to tell from this. It was also then spliced at some time with some plastic wire into the cloth, and generally a not well performing mess of wires, and it's been replaced. I'll describe a little more of the work that was done on each of these, but for now let's continue with just showing the roller test in action. Now you can hear the wheels on the rollers. You can tell that they're getting a little roll resistance. There's weight on the motors. You can still test at lower speeds and see how it does against those low voltages well below reverse unit activation, but you might be crawling around the track, doing a little yard work, that kind of thing. And then as well, how fast you can spin up and run as well. As I mentioned, these have all been worked on and finished. The reverse unit. And so that's a roller test. And it's good because it'll indicate to you different things about the performance than the hang test can, but that's a good place to start. And then of course the next step after even the roller test is to put the side frames back on, run it without the shell out on the layout, and then when you're completely satisfied with that, then put the shell back on and make it a complete engine again, ready for operation. A little bit about each of these engines. They did require overhauls. As I mentioned, this one's truck was shot, but there was a spare on hand that was in good shape, so that got utilized. The reverse unit was overhauled and worn out fingers replaced, drum polished, things like that. And then all the bits and pieces that are in this motor checked for wear and tear, as well as cleaned and polished. This one was in very much the same condition. It's two trucks bushings were shot, so they were removed and fresh bushings put in, armatures, etc., all removed, polished, cleaned, and checked for wear. And the brush sets were replaced because they were pretty badly worn as well. And then the reverse unit wasn't working, so that got disassembled, cleaned, polished, and the worn out fingers that it had replaced. This one in the back was the most seriously in need of attention. Its wiring was that mangled mess of wires that I showed you earlier. That's all been replaced now by new rainbow wire and Superflexi 22 AWG wire for things like the headlight. Now, in transforming this from the original cloth covered wire to the new rainbow wire, there used to be 1/4 inch holes with rubber grommets around them for the circular cloth covered wire harness to pass through. That's not going to work with the flat plastic covered ribbon or rainbow wire instead. So the holes that were here got bored out to be larger ovals, and then new nylon grommets installed so as to continue protecting the wire passing through those holes in the sheet metal frame. For some pictures of what that looks like as a work in progress, visit my website at precisionflyerrepairs.com, and you'll see some of that work while it was taking place. The trucks on this engine had worn bushings, and those needed to be replaced. They also threw unusual curves at me because at first with this one, no matter the combination of gears and bearings and even different armature, one end just wouldn't spin as freely as the other. I was able to work that out with this one and keep the original truck, but I ran into a similar and more serious condition with the other black truck and needed to resort to a spare 360 truck that the customer had also sent along that needed its bushings replaced and to be completely stripped clean and degreased, but it works much better in a similar fashion to what this later production 360's trucks responded and performed like. And all that I can think of is in these original black trucks there was some misconfiguration of front to back that actually prevented the armature from ever leveling completely as it ought to. I was able to work through that on this one, and it spins and runs very nicely now. But the second one, its sister, just, well, no matter what I tried, wasn't able to compensate and overcome that. So I had to resort to the spare truck that, fortunately, the customer had. Of course, I can procure those and have some. But when the customer sends spares along intending for them to be used if needed, I'll use them, and it was very thoughtful that he did that. Then the brushes on this unit were also replaced, and pretty much again a fresh lubrication, of course, front to back, and making for a complete overhaul. So hopefully that gives you some ideas of things to look for and inspect before and after your work, as well as a hang test to perform before and after your work, and a roller test to perform before and after your work, and perhaps a tip or two on rewiring an old 360 that was cloth insulated wire at first with the new plastic insulated rainbow wire instead. And by the way, the rollers that I like are by Bacchus. They're terrific. They also have solid metal saddles, they call them, for putting under tenders and other wheels that need the pickup power but are not powered. And I've had mine for years and use them all the time. They're terrific. They're adjustable from HO to S, or you can buy them in different gauge selections. So without any further ado, thanks so much for joining me again, and a special thank you to those who subscribe to my YouTube channel. I really appreciate that, and it helps you know when I post new material, which I do hope you find interesting and helpful. And for more information, please feel free to visit my website at precisionflyerrepairs.com. Until next time, be well, have fun running your trains. Thank you.